Alright, and here we are in a parallel RCL circuit. We're going to do calculations. It should be fairly familiar. You're already familiar with RL and RC, and we've looked at series RCL circuits, so there aren't too many differences. Alright, let's get started. So you're going to start with your ohmic values for your two reactive components. So XL is 5.28 k ohms. And XC is 9.95 k ohms. Now, when you put these two into your ohmic value formula, your impedance formula, it is particularly important that you do them in order. So, for instance, your inductive reactance and your capacitive reactance, they have to be inverted and subtracted from each other before they are squared. So they must be done in that order. So please pay attention to this on order of operation. It is particularly important. Alright, impedance you get for this one is 7.03 k ohms. Once you have impedance, you can get current. Voltage divided by the ohmic value gives you 7.68 milliamps. And of course, now we can look at currents. So we have voltage of 54 divided by 9K, which is the ohmic value of branch 1, and we get 6 milliamps. Now we do branch 2, which is voltage divided by the inductive reactance, and we get 10.23 milliamps. And then we do branch 3, voltage divided by capacitive reactance, and we get 5.43 milliamps. Now, the current formula should be quite familiar. It's similar to the series impedance and the series voltage formula. So all we do is take our current through one branch and subtract the other branch. Again, it doesn't matter which one. If you get a negative number and square it, you will get a positive number. Okay. So we take our 6 milli for branch 1, which is the resistive current, and the difference between the inductive and capacitive current, which is 4.8 milliamps, and we square each of those, add them together, and then square root them. And we should come within a hundredths, maybe tenths of 7.68 milliamps. Now remember, we've done a number of these. The only difference between coming up with exactly the right answer or being a hundredth or tenth off really just comes down to rounding. It's just how accurate you are in your rounding. Typically I do standard rounding. It generally gets fairly close. You might be a little off, but don't be concerned. No big deal. Now, of course, in this particular case, all the voltages are going to be just the same. We are going to have 54 volts on R1, 54 volts on L1, and 54 volts on C1. And that, of course, is because voltage is constant in a parallel circuit. Each one of these branches only have one component, so you will see the applied voltage on that single component in the branch. Alright, and that is it for parallel RCL circuit calculations. So the really big thing to remember is that impedance formula. It's a tough one. You really have to pay attention to the order of operation. And a lot of people decide to skip that and just take the current route, which you can completely do. If you figure out each of those currents, you can use your current formula. Voltage divided by current will give you impedance. So you can get it that way too. Alright, next we'll look at resonance in a parallel RCL circuit.